Good morning to everybody. I am Dr. Krishna Mohan, Dean Mechanical Building Science of E.G.S Engineering College. I am very much proud to introduce my friend Mr. Anwardin for this webinar presentation. Mr. Anwardin and me studied BE Mechanical in the year of 87-91 in Mugambay College of Engineering, Trichy. After the completion of engineering degree, Anwardin joined in a private concern Sagayam Industries in Chennai, Sagayam Industries. Then, after getting the experience, he went to Singapore. Then he started a own company in Singapore in the manufacturing unit of heat exchangers. Now he is the sole proprietor of the NSK heat exchangers. Now I request our principal to welcome our chief guests and the participants. Thank you, sir.
Good afternoon and namaskaram to all. It's our great privilege and blessings to have this webinar. This webinar is about the concept of industrial heat exchangers. This webinar is conducted by our Department of Mechanical Engineering. Here we have a great personality and international expert in this field, Mr. N. Anwardin, Managing Director, NSK Heat Exchangers Private Limited, Singapore. He is going to share his knowledge and experience with all of us. So this webinar will be very fruitful and useful to all of us. With this few words, I request all the participants to use this webinar for your enriching knowledge and experience. You can have a great interaction with our webinar presenter by posting your queries in the chat box. So I request all of you to use this golden opportunity for the betterment. Now I request Mr. N. Anwardin, Managing Director, NSK Heat Exchangers Private Limited, Singapore, to go on sharing his experience and knowledge with our participants. Sir, please.
Thank you, Dr. Krishna Mohan and Mr. Rambalan, Principal of E.G.S Pillay Engineering College. Okay, I myself, since they have given introduction about me, I'm Anwardin, Managing Director of NSK Heat Exchangers Private Limited, which is established in Singapore in the year of 2008. And I welcome to all the participants on this good evening, and let's go for the presentation about the concept of industrial heat exchangers. Thank you. Can we go for the slides?
Yes, sir, please.
Okay, now we start this webinar, the subject about concepts of industrial heat exchangers. The industrial heat exchanger is a one equipment. Sorry. I think just now we have discussed about the history of our small history about our company and myself. Then we go to the next one. We come to the technical points now. What are heat exchangers? Maybe we all know that heat exchanger is an equipment that transfers heat from one medium to another as a result of temperature difference. Example given from hot water to cold water, from steam to cold water. This heat exchanger is one of the main equipment for the refineries, chemical plants, and process and power plants, and any type of process plants. The heat exchangers, when you talk about heat exchangers, there are several types are there. One is cell and tube type, plate type, and thin fan cooler. It depends on the application side. For convenience of the plant, the heat exchangers are going to be designed and constructed. Now, for today webinar, we will talk about the cell and tube type heat exchangers, some more details so that you can understand. Before we go into the details of the heat exchangers design, let me let me give you the table. How the subjects are covered during your UG studies. Many students think that some subjects are useful or some subjects are not useful during the studies. But I don't think, I disagree. I think we are covering about 52 or 54 subjects in the BE course. And once you enter to the second year BE, mechanical especially, you study a lot of subjects, and all the subjects are going to be useful when you are going to work as an engineer in any firm in the future. Okay, for these heat exchangers, these are all the subjects you are going to use when you are actually using the heat exchanger design or construction or maintenance. For example, heat and mass transfer. We call it in small way HMT, which is talk about heat balance. We have a thermal engineering subject, which is talk about heat balance and coefficients. Then, of course, engineering drawing and CAD. This is regarding drawing preparation. Then you might have studied about metallurgy, which is for material selection and properties. Then metrology and measurement, welding technology, strength of materials lab, thermal lab, and engineering workshop. All these subjects, when you, some of you already studied, or some students going to study. When you study, better be prepared these subjects very well. If you are enter into the heat exchangers or any pressure vessel components, fabrication, design, manufacturing, maintenance in future in your life. The cell and tube type, as I told you, there are three types: cell and tube, plate type, and fin fan cooler. The most basic and common type of heat exchanger construction in the cell and tube is, later I show you the figure. This type of heat exchanger is consists of set of tubes in cell. The fluid passing through the tube is called the tube side. The fluid flowing on the outside of the tube is in the cell side fluid. At the end of the tubes, the tube side fluid is separated from the cell side by the tube sheet. The tubes are rolled or welded onto the tube sheet to provide a leak tight seal. This is the simple schematic diagram of cell and tube heat exchangers. You can look at it here. The arrow mark, tube inlet. That means the tube fluid is going through the tubes all the way coming out tube outlet. Then cell side, there is a fluid will come here, will pass through the baffle, and will come out from here. From here, what happened? For example, the tube inlet, if you give a cold fluid, the cell side, if you have a hot fluid, what happened? This cold fluid will take the heat from hot fluid. Then cold fluid become hotter, the hot fluid become bit colder. This is the purpose they are using heat exchangers in the process industry. Why they are using cell and tube heat exchanger? You may have a question. Why cannot mix? For example, we have a hot fluid, cold fluid. Mix it, become colder or hotter. No. When you do process, you cannot mix the fluids. That is the reason they are using cell and tube heat exchanger, and the heat transfer is taken by convection method. When you talk about the heat exchanger design, there are two aspects we have to look into the design of heat exchangers. One is thermal design, another one is mechanical design. What is thermal design? Thermal design is to calculate heat balance, heat transfer area, and sizing of the equipment. First, we have to see how much heat required to warm the fluid or cold the fluid. Based on that, you have to see what is the temperature difference. From the temperature difference, you will get how much heat transfer area you require. Once you find out the heat transfer area, you will size up the equipment. For example, 2 meter long, 3 meter diameter, something like that. Once finished the thermal design, we will look into the mechanical design. What is mechanical design? Mechanical design is to check the integrity of the equipment, whether the equipment will work under the pressure or temperature or not, or whether we select the right material or not, or whether we have a proper thickness of the components. In order to check the mechanical design, you will check tip sheet, tube, shell, channel, nozzle, and flange rating components, which is the pressure parts components in the heat exchanger design. When we check into the thermal design, as I told you earlier, you have to do a heat load calculation. Heat load calculation is a very simple formula, which is same formula for every time. Q equal to mCp delta T or T1 minus T2, or you can say temperature difference, where Q is a heat load, mass is mass flow, Cp is a specific heat, T1, T2 is a inlet outlet temperature. From here, you will find out the heat load, how much heat load required. Once you find out the heat load, you have to find out the heat transfer area. Heat transfer area is A equal to Q divided U times LMTD. You may heard this new term. What is mean LMTD? LMTD is a log mean temperature degree centigrade. U is a heat transfer coefficient. Heat transfer coefficient, then once you get the heat load, you will come to know the heat transfer area. So this is the thermal design. After that, you will go for mechanical design. I'm just giving you all a simple example. Later part, when you go for actual thermal design, there are a lot of factors that need to be considered. Nowadays, many softwares are available. Later, I will explain you. When you come to the mechanical design, what is the importance of mechanical design? Heat exchangers are pressure parts, and a careful mechanical design shall be applied for integrity of the equipment, and even required statutory approval from government bodies, especially when steam medium service is involved. Okay, simple formula I'm giving you here to find out the minimum thickness of the cylinder components. P equal to PR divided by SE minus 0.6P plus C. Okay, here T is the minimum required thickness. For example, you have a 500 mm diameter cell for 10 kg per centimeter square design pressure. Then you will come to know, when you calculate, you will come to know the minimum thickness of the cylinder components. Say for example, if you have the calculated thickness is 10 mm, if you use actual component thickness 6 mm, the equipment will burst. Also, the calculated thickness is 10 mm, you use 20 mm thickness. What will happen? It is a loss of, it is a waste of money. And people cannot invest so much capital investment. That is why you have to do a proper mechanical calculation, mechanical design. When you talk about mechanical design, there are design codes are available internationally. Some of things are ASME, TEMA, E.G.S, I.S, E.N, and APA. I think you all know what is I.S. I.S is a Indian standard. ASME is very popular. It's called American Society of Mechanical Engineers, which is control body of designing of mechanical design for all the pressure parts. TEMA is a special one for Tubular Exchanger Manufacturers Association, which is designed for specifically heat exchangers. BS is British standard. APA is American Petroleum Institute. So when we talk about the mechanical design, once done the mechanical design, then you go for the fabrication, or next is the drawing preparation. Before that, I want to ask you for this, I want to tell you for the areas of application where the heat exchangers are really work. Chemical plants, process plant, refineries, oil and gas industry, marine industry, power and gas plant, fertilizer plants. Okay, in this photo you can see, this is called heat exchanger. In any refineries or plants, you go there, you can see at least one refinery plant, you can find 1,000 over heat exchangers because the refineries are required a lot of process. Since your college is situated near the Nagapattinam, you may come across or you may go through this Narimanam area where you can see this ONGC refinery plant. There you can find all the tall towers, heat exchangers, pressure vessels. Okay, we come to the material of construction. Heat exchangers are built in various material combinations for both shell and tip side, depends on the application side, how they want it. Example given, carbon steel, stainless steel, copper or brass alloys, titanium, monel, inconel, zirconium, etc. There are so many materials are available. These materials all select based on the process requirement, cost, and life of the equipment. For example, if you want to use a seawater application, you cannot use a carbon steel or you cannot use a stainless steel because the seawater is very corrosive. For that, you have to use a copper alloys or titanium. If not, there are some hydrocarbon materials, hydrocarbon process in the refineries, where some places need carbon steel only. If not, you have to use stainless steel. It all depends on the client requirement. Based on the client requirement, then we have to design the heat exchanger. When we talk about design, we are in millennia. After the year 2000, there are many softwares developed. Mechanical engineers' work are taken away by these softwares. You no need to physically do all these paperworks, not like those days. When you do, you have to do for 20 or 30 pages of mechanical calculation. Now, there are softwares available for both thermal and mechanical design. Namely, for thermal, namely HDRI, HDFS. For mechanical, you can find PVLI, compress. But when you know this design software, you must know the concept of the heat exchangers. Otherwise, we do not know what we are giving input, what we are taking output. So, it's my personal advice. You physically do a calculation, thermal or mechanical, manually, sometime for 3 or 4 times. Then you will come to know. Then when you use the software, you will come to know the real effect of the sizing. Or at least you should know the input parameters. Then only you can control the output parameters. You see this picture. This is one of the software we are using in our organization for mechanical design, which is called PBLite. Here we put this heat exchanger. You can see looks almost similar like a heat exchanger. Same heat exchanger, I will show you the drawing, I will show you the actual product now. Okay, the heat exchanger, though all are called cell and tube heat exchanger, there are nomenclatures are there for the heat exchanger. According to TEMA. TEMA is Tubular Exchanger Manufacturer Association, as I told you earlier. You can find here, A. Someone, okay, when you join after BE, you join a heat exchanger company, they will talk about BEM type heat exchanger. What is BEM type heat exchanger? You all know, I know only cell and tube heat exchanger. What is BEM type heat exchanger? Here you can see cell and tube. Under the cell and tube heat exchanger, you can see B, E, M. This is the construction method. B means this bonnet type. E is a cell. M is a rear end type. You can see here B, E, M. BEM type. Other type we can say AEM, BEU, or AES, etc. It all depends on the application and the process requirement. This is the typical heat exchanger drawing, where you can find the drawings, and take note that heat exchanger, when you do a heat exchanger, the drawing accuracy is very, very important, and it should be very carefully checked before you go for fabrication. Why? The heat exchanger, after finish all the fabrication, final testing only, you will come to know the problem. If you know the problem, very difficult to solve the problem because the component is already assembled. That's why stage inspection from raw material to until the testing is very important in heat exchanger construction. Just now you saw the software, I show you the figure, and I show you the drawing. Now I show you the actual product of the same heat exchanger. You can see here. This is the heat exchanger. It was built by us sometimes ago. You can see here, this is cell, this is saddle, this is tube sheet, this is channel, I mean tube side. So the fluid is going through the channel, coming out. The cell side fluid is going here, coming out. These are all the heat exchanger components. It's called tube sheet, where the tube holes are. Tube holes made, and the tube will pass through this tube sheet. This is the buffle plate, where the heat exchanger skeleton made. This is the support plate. This is tube. This is a channel cover. This is the first point of assembling the heat exchanger. It's called bundle skeleton. We put the tube sheet one side, and we spread the buffle plate with the help of spacer, so the skeleton is getting ready before put the tubes onto the bundle. This is the completed bundle with all the tubes inside. Then this is the area where the bundle is going inside the cell before welded the tube sheet onto the shell. After assemble the cell and tube sheet, the tube need to be welded or rolled ended. Again, depends on the pressure. The pressure means, say for example, if you have a 50 bar pressure, you do only a torque controlled tube expansion, it is not enough. So the tube end to be welded. If it is low pressure, you no need to do welding, just you can do a rolled expansion. Here some of the heat exchanger other photos with bellow. It's called expansion bellow. Why we need it, expansion bellow? Because if there is a temperature difference too huge between cold fluid and hot fluid, then there will be a thermal expansion in the cell body. So you have to put a expansion bellow. It is not necessary that all heat exchangers should have this bellow. Only it depends on the application and depends on the temperature difference. Sometimes the heat exchangers comes with stacking type, 1 and above, because usually the refinery plants, all the plants, the spaces are very constrained. So you cannot have a very big spaces to keep all the equipments. So they put 1 and above. This is called stack type heat exchangers. This is another type heat exchangers where you can see with the nozzles with the common inlet outlet flows. This total weight is around 9,500 kgs. You can see here, this is another BEU cell and tube heat exchangers. It's completely made out of CS, carbon steel material, around 8,500 kgs. You can see here so many bolts and nuts because heat exchanger pressure retaining parts are mainly held by the bolts and nuts. So hold by the flanges and the end cap. This is called NEN type cell and tube heat exchanger with the material SS304H construction. Overall length is 12 meter, built by us. Empty weight is around 6,500 kgs. So this is a very long length, and the heat exchanger can be designed in so many length and so many convenience, either of diameter or length or any convenience. It all depends on the plant requirement. This is a BEU with a combination of 316 stainless steel, carbon steel, aluminum, brass, all. When you talk about tubes, you can find U tubes also, because sometimes the thermal expansion is very big, and even you put 3 bellow or 5 bellow or 6 bellow, still the thermal expansion cannot take care. But no choice, you have to use for the thermal expansion. Then we come out with U tubes. The U tube is having a thermal expansion, free thermal expansion. That's why people use U tube bundle. Some of the U tube bundles. Side tube bundles for floating tube bundles. Now, we come to the heat exchanger. Usually heat exchangers are good under normal operating conditions for 12 to 15 years. After that, what to do? Do we need to throw this equipment or can we recondition it? Yes, we can recondition it because you don't need to throw it. Because, for example, here you see 19 tons. People don't want to throw. So what we do, we remove the existing tubes, old tubes, and put a new tubes and put back to the service. At least instead of 12 to 15 years, the service will enhance for another 5 to 6 years. Okay, at the beginning of my presentation, I told you another type of heat exchanger is called fin fan cooler. Yeah, this is the model. Sometimes the cell and tube heat exchanger is good for some application, especially for two fluids, hydrocarbon fluids or any cooling water, any process. Some fluids, you need air to heat up or cool down. For that purpose, they use a fin fan cooler type. Mostly for fin fan cooler is used for condensation purpose. It is a small difference will come. That's all. This is how it looks. Underneath of this fin fan cooler, there will be a fan to force through the air from the bottom. Okay. We are almost finished the technical presentation. We are coming to here. You may have a question. How you all can work in this industry? Especially for the heat exchanger manufacturers or pressure vessel manufacturers. Usually when you go to any heat exchanger company or pressure vessel company, these are all the departments normally available. The project department will take care of all the equipments from once the sales department hand over the order to the project department. Project department will liaise with other internal department until the delivery of the equipment. Inside this, under this project department, there will be an engineering department. The first department will involve who will take care of the thermal design, mechanical design, and detail engineering. Once they finish, then QA/QC department will come. This QA/QC department will take care of the quality of the equipment, inspection, documentation. Production department will take care of the schedule, manpower resources, and safety of the production site. Once you finish all these things are coordinated, the project department will liaise with client and end user before or during the fabrication process. Let me discuss a little bit about the QA/QC department. As I told you, the heat exchangers are pressure parts equipment, hence a careful quality control procedure and check required for integrity of the equipment. All welding work shall be carried out by a qualified welders. We cannot ask the people to do it. The welding work shall be done proper quality management. The proper quality management means you can find welding procedure specification, procedure qualification record, welder performance qualification test. All these things you can find like a WPS, PQR, WQT people talk. When you come to the job market, people will say okay, WPS, PQR, WQT. So you will come to know all these words. Then necessary non-destructive works need to be done during the course of fabrication of the equipment, namely called PT, liquid penetrant check, radiography testing, magnetic particle testing, ultrasonic testing, ultrasonic thickness gauge measurement, positive materials identification. So all these things are called NDE, NDU works. When you see NDU works, this picture will show you. This is called UT, ultrasonic test. It will check the material surface integrity, whether the material have any crack or any discontinuities to before do the welding or after do the welding. This is called liquid penetrant test. Liquid penetrant test, after do welding, they use a thinner and a developer to check is there any crack or any metal discontinuity in the welding area to find out. If there is, then the repair to be done before delivery. It's called magnetic particle test. The magnetic particle test is there is a MPA machine which has a North Pole, South Pole magnetic. Then they will use and check is there any crack on the welded surface. It's called positive material identification. Some people suddenly, when you do a material is there, no tracing. How to check whether this material is stainless steel or not? There, this positive material identification will come. This machine will help you to check the material, whether it is a stainless steel or copper or brass or carbon steel. This is called positive material identification. To make it easy to understand, this positive material identification, you all very frequently see where when you go to buy jewelry shop, big jewelry shop, they have this machine. When you buy a gold, you ask them whether it is a 916 or not, and they will put this gold into the machine, and the machine will show you the percentage of the gold, purity of the gold, 916. Next time when you go there, you can check. But of course, when you go and tell them PMI machine, I don't think they will understand. They will say it's a gold purity machine. Okay, we come to the final documentation and dossier. All these things done. all the fabrication finish, equipment going to deliver, but what is the record they have? So you have to give drawing, calculation, all the NDE works, QAQC record, everything put into one file, which is called final documentation or dossier, or we call it MDR, manufacturer data record. This book will go to the client's library, because when they want to do maintenance or anything, they will refer this file. So I am coming to the end of this session webinar, and thanks for all your participation. And if you have any questions and answers, you can ask me. And let me show you one time-lapse video of how the heat exchangers are fabricated. Then you can see very clearly.
Sir, no, sir. Video play பண்ணுங்க sir. Anwar sir. Video play பண்ணுங்க sir. முடிச்சிட்டு question கேட்டுறோம்.
Lapse manufacturing process. Stainless steel plate is rolled for the fabrication of the heat exchanger shell. The shell sections are joined together. On the left-hand side, the baffle cage is being prepared. The expansion bellows are point welded to the shell. The shell section is complete, measuring 7 meters in length. The baffle cage reaching its completion. Working around the clock to meet the promised delivery date. The baffle cage is placed in the shell. The first tubes are inserted one by one. Only the first tube plate is welded at this time. Positioning of the second tube plate. The remaining tubes are inserted. When all the tubes are inserted, they are point welded to the tube plate. Now the orbital welding and roller expansion work can begin. Two operators begin the orbital welding. Tubes are welded in a zigzag pattern to avoid tension on the tube plate. The tubes are roller expanded, assuring a perfect fit. The unit has been pressure tested and is prepared for transportation. Specially manufactured saddles are used to support the unit on the truck. A 16-ton lift. Job done.
Hope you all enjoyed this video. Mr. Krishnamohan, is there any
Yes, sir, I am on
answer?
the line. Participants have asked some questions, sir. First question, Mr. B. Karthikeyan, he asked one question, the difference between the QA and the QC, that is quality assurance and the quality control.
Okay. Okay, the quality assurance and quality control is what? Quality assurance is you have to prepare a document for your company. For example, WPS is a quality assurance. That means we are going to follow these qualities in our company. So you have to written procedure. Okay. When you do actual welding, you go and see the welding defect or welding quality on the actual welding. Can you hear me? Hello?
Yes, Anwar, yes,
Yeah.
Anwar. Yes,
Okay.
sir.
The quality control is an inspection side. Quality assurance is a document side. For example, how you are going to do the hydro test on the equipment. When you have a document, yes, I am going to do for this equipment, okay, for this pressure, for this holding time, and after some time, I am going to offload the pressure. It's called quality assurance. Quality control is to implement the quality assurance on the actual side. That is the difference between QA and QC.
Thank you, sir. The next question from Asik. What is the full form of NDE, sir?
Non-destructive equipments. Non-destructive equipments means you should not spoil the equipment, but you have to test the equipment. You have to test the plate. For example, you want to check the plate thickness, but you don't want to go and disturb the plate, or you don't want to scratch the plate. So that is called non-destructive equipment. The meaning itself is coming non-destructive.
So next question. What type of welding is suitable for this heat exchangers fabrication?
Okay. When you talk about the heat exchanger welding is a very vast area actually, and everybody knows that. Welding is one of the very beautiful art of technology in mechanical engineering field. After 1950s only, they come out with a very good welding technologies. Okay. For heat exchanger, all welding is suitable, depends on the pressure rating for the heat exchanger. Okay, there are three types of there. One is GTAW, SMAW, SAW. Okay, what is meaning of GTAW is gas tungsten arc welding, which is usually used for very thin thickness of material. For between tube to tube sheet, the welding, because the tube thickness is 1 mm, so we use GTAW or tungsten inert gas welding. Whereas when you do a full welding, higher thickness, you go for SMAW, which is called submerged arc welding, which you can see normally in our area where the grill operator, all these people are doing the window grill, they use arc welding.
Yes, thank you, Anwar. Next question from one more participant, Mr. Logesh Kant asked a question. Which type of heat exchanger is more efficient, a shell type or tube type or plate type?
Okay. Again, I told you in the beginning of the presentation, every type of heat exchanger have a own advantage and a disadvantage. For example, plate type. When you use a plate type, the plate type maintenance is very difficult. You have 100 plate. In between one plate is leak. What you have to do? You have to dismantle the whole heat exchanger to remove the one plate. Whereas cell and tube, you have 100 tubes. One tube, if you have a problem, you can plug it. Okay. Second is the cell and tube heat exchanger usually give a very long life compared to plate type heat exchanger. And the plate type heat exchanger usually for very low applications like a water to water medium. Whereas cell and tube heat exchanger, you can use it for phase change from gaseous state to liquid state to gaseous state. Hope I answered that question.
Yes. Yes. Thank you, sir. One more participant, Mr. Anthony Brooklyn J. If BEM heat exchanger is totally differ from normal shell and tube heat exchanger?
No. Again, I told you, shell and tube is a generic name, general name, shell and tube. Means shell and tube heat exchanger means there is a cell, there is a tube. Under the cell and tube heat exchanger, there is a, because people, why they come out with the BEM, AES, AEM, all, this Tubular Exchanger Manufacturer Association in USA, they come out to standardize the type. Otherwise, people don't know which type they use. They want to control the quality. That's why come out with the BEM, AEM, BES. But again, I am clarifying to the person who asked question. Cell and tube is a general name. Under the cell and tube, there is a BEM type.
Yes, sir. Sir, thank you, sir. Next, one more participant, Dr. M. Shanmugapriyan, Head of the Department Mechanical Engineering, Layla College of Institute of Technology. What is the cost of heat exchanger normally and the reconditioning cost? Compare both. Any new type of heat exchangers available in the market from existing heat exchanger for using high temperature applications?
Okay. For the heat exchanger prices or cost wise, if you talk about it is very difficult to tell just immediately, because it is depends on the material how you use. For example, you use a titanium material, you use a carbon steel material. So carbon steel, compared to carbon steel material, titanium materials are around 40 to 50 times costlier than carbon steel. Again, what he asked for any new type heat exchangers. Nowadays, there is a new technology is developed. People start using for spiral type heat exchanger. Spiral type heat exchanger is still not so popular in the market because it's quite expensive. It can accommodate small space with more heat transfer coefficient. I mean, heat transfer duty is very effective. People use it for spiral. For high temperature, what he is asked, he has to go for BEM type with Bellow, with probably he has to go for chrome moly grade 11 tubes for high temperature application. We call it in industrial for tube material A213T11 grade. Hope I answer for his question.
Sir, one more question. What are the safety standards to be followed in the manufacturing the heat exchangers?
Manufacturing the heat exchangers in the industrial, you have to follow the industrial safety. Industrial safety means you have to have a normal PPE and all the norms you have to follow for any Factories Act, according to the Factories Act. But when you use a steam piping service or steam service, you have to follow local governing body. For example, in India, people might have heard, I think you know very well, IBR, Indian Boiler Regulation. So any steam piping or any steam service involved in the heat exchanger, your drawing, material, all must be pre-approved by IBR. Without their approval, you cannot do any heat exchanger, because they will act like a third-party inspection agency. Because when you do a steam heat exchanger, the client go and install. If there is any problem in quality, the heat exchanger bust, then people lost their lives.
Yes.
So this is the situation. So you have to take care of the governing body whenever there is a check.
The standard of IBR regulations is only for India. Like that, Singapore and other countries also, same
Yes.
standard will be different, sir.
Different. But the concept is different. What they ask that in India we call it IBR. In Singapore we call it MOM. In Malaysia we call it DOSH. In America we call it ASME U stamp. Okay. In Europe we call it PED, Pressure Equipment Directive. But the concept is same. Because they want to mainly they want to control the quality. They want to make sure the equipments are safe before put into operation.
Yes. Okay, sir. Our student can learn the IBR only. In India, they can learn IBR only. How will how to learn the standard of Singapore and Malaysia and other countries. Then only they will get the job opportunities in other countries. Yeah. How to learn those standards in India? Is there any website or anything is there? Book?
Okay. It is not necessary they have to go and study specifically for these rules and regulation of other countries. But what they do it is that, see, again I am telling you, the design calculation is same. For example, you do design calculation under ASME, which is approved by IBR, which is approved in Singapore, which is approved in Malaysia also. Only thing is the fabrication, the inspection point, and the quality checking is done by them. But it's a still same quality. But there will be a small difference will be there, minimal, very minimal difference will be there. For example, I can tell you offhand, as we allow for 1.3 times of design pressure for hydro test, for example. If you go to Malaysia, they say 1.5 times of hydro test pressure. That's all. There is nothing difference. Still calculation is same. There is no need. If they want it, they can go to the specific department. They can get the code of practice. They can see what are all the minimum standards need to follow, which is widely available in all the websites.
So one question from Mohammed Moinuddin. Which is the leading company of manufacturing heat exchangers in global?
Okay, in global, it is okay. I can tell you people like Yuba heat exchangers. They are in America. They are almost. I did not physically visit their facility, but I heard it is almost like a same like a Nagapattinam town.
Yeah.
That capacity.
Factory.
Then why don't you go that way? Then you go to the BHEL Trichy. BHEL Trichy is one of the biggest manufacturer for a heat exchanger, and L&T is a very big heat exchanger company in India.
Yes. Oh, very good. Okay, sir. I hope all the participants enjoyed this session. Now I request Mr. Sundar, coordinator of the program, to give the vote of thanks. After the vote of thanks, Mr. Anwardin will give some suggestions to our students. Then we will close the webinar. Now I call Mr. Sundar to give the vote of thanks. Camera on.
Morning to everyone. It's my privilege to have been asked for proposal for time in this occasion. On behalf of the Local Department, I would like to thank our research person, Mr. N. Anodin sir, for his excellent presentation. And then I would like to thank our Honorable Secretary and Trust members for the motivation. And special thanks to our CEO sir and the Principal sir for their excellent support right from the beginning. And I extend my sincere thanks to Dean, Dr. Krishnamohan sir and Dr. Mechanical Urumurthy sir for their excellent support. And I would like to thank all the department faculty members for their contribution and support right from the beginning. Last but not least, I would like to thank all the participants for making this webinar in a grand successful manner. Thank you very much. Thank you all.
Anwardin sir?
Yes.
We need some suggestion for our students, sir.
Okay. Suggestions that, I hope they all in third year and fourth year students. What they can do is once the BE course is finished, they can go to the job. But of course, I don't think they will get a big company's opportunity immediately. What they can do is they will look for a small companies where they are having a hardly 10 people or 20 people employed by those companies. There you are free to learn all the things, basic things you have to learn. How the weldings are being done, how the fit up are going to be done, how the testing of the equipment is done, how they are purchasing the material, how the materials are being inspected. All these things you can learn as a one person. So I suggest I started my career in that way, and As Dr. Krishna Mohan knows that we worked in Sakai Engineering Works, which is just a 3% companies in Perambur, Chennai. He started. In fact, he was one of the very popular contractor in IBR industry. And so this is why don't look at it for the company entrance, how big it is, how small it is, what you are going to learn. That is more important. The compound may be very small, but you can learn many things. When the compound is very big, you are restricted to learn many things. If you have a big company, so you go and join, they have a swipe card system. Design department cannot go to production department. Production department cannot go to the QAQC department. And these people cannot go to the sales department. So all this, but I'm not against joining in big company, I'm telling you. But whatever the opportunity you got it, you go and learn it. You go and learn it, then it will give you a bright future for your life. So what I told you today is about heat exchanger, which is same applicable to any pressure parts equipments fabrication, like a pressure vessel or piping or any reactor vessel or everything. So after finish your BE degree, try to find a job. I know it is not so easy task. Even those days also it is not so easy task. But still, you have to try hard to do it and get it done and work honestly. And one more, my sincere request I'm telling you, whenever you go and join any company, try to spend some minimum employment period with them. Don't look after the dollars. Don't look after the rupees. Okay, there is another company is trying to give me another $1,000 extra. Don't do like that, because they are the first people who gave you opportunity. Always together we grow. That is very important. Company also must grow. You also must grow. That is the most important. You have to take this message. Anything else, sir?
Sir, thank you, Mr. Anwarjan. One more request. Whenever you come to India, I request you to visit our college campus and give a live explanation and sharing your thoughts. It will be very much useful to our students. This is our request from our management. Whenever you come to India, you please come to our college to share the experiences. Okay,
Sure,
sir?
definitely.
Thanks for your presentation, and I thank all the participants. Now let us close the webinar, leave the webinar. Thank you all. Thank you, Anmandit. Thank you.
Thank you very much.
Thank you.